Mercury is the closest planet to the Sun, yet it remains one of the most mysterious. For centuries, we observed it from Earth, but never truly understood it. Why does such a small planet have such a powerful magnetic field? And why are there signs of ice on its surface despite the extreme heat? Mercury is the fastest planet in our solar system. It completes a full orbit around the Sun in just 88 Earth days. But it rotates slowly. One Mercury day lasts 59 Earth days. This creates a strange effect. You could see the Sun rise twice in one day. During the day, Mercury's surface heats up to 430 degrees Celsius. At night, it drops below -180 degrees Celsius, a dramatic swing due to the lack of atmosphere. No other planet experiences such extreme temperature changes. This makes Mercury harsh, yet perfect for studying airless environments. Mercury has almost no atmosphere. Its gravity is too weak to hold gases against the force of the solar wind. Instead, it is a thin exosphere, a shell of atoms knocked off the surface. That means no sound can travel there. Complete silence. Beneath Mercury's surface lies a giant metallic core. It makes up nearly 85% of the planet's radius, more than any other planet. Scientists believe this core is partially molten and generates a magnetic field. But why is it so massive? Theories point to a long-lost cosmic catastrophe. Scientists believe that Mercury once collided with a massive celestial body. This event could have stripped away much of its mantle, leaving behind a huge metallic core. Such a hypothesis explains the planet's unusual density. It may have been one of the earliest and most violent catastrophes in the solar system. Despite its small size, Mercury has a real magnetic field. It's about 100 times weaker than Earth's, but still active and generated from within. This surprises scientists, especially since Mercury lacks a thick atmosphere. A partially molten core is likely responsible for this invisible force. From orbit, Mercury appears as a scorched, crater-covered sphere. It resembles the Moon, but with metallic glints on its surface. Countless impacts created massive craters and ejecta rings. Each crater is a silent witness to ancient cosmic collisions. One of Mercury's largest craters is the Caloris Basin. It was formed over 3.5 billion years ago by a colossal asteroid. Its diameter spans more than 1,500 kilometers. Around it lie rings of faults and ridges, like waves frozen in rock. Unlike Earth, Mercury doesn't have tectonic plates. Yet, its surface is filled with folds and cracks. As the planet cooled, it shrank slightly, causing the crust to wrinkle. These wrinkles are called scarps and stretch across the surface. Mercury is the closest planet to the Sun, only 58 million kilometers away. It receives 7 times more solar energy than Earth. But the heat doesn't linger since there's almost no atmosphere. The sunlit side heats up instantly under the blazing light. At Mercury's poles, deep craters never see sunlight. Within these eternal shadows, scientists found signs of ice. How it got there remains a mystery. Perhaps comets or asteroids delivered water billions of years ago. Many scientists think comets helped spread water through the solar system. Comets are icy bodies traveling at immense speeds. If one struck Mercury, water could have stayed in its shadowy craters. This is one of the leading theories about the origin of water on planets. In 1974, Mariner 10 became the first spacecraft to visit Mercury. It sent back images showing a cratered surface much like the Moon. It also discovered Mercury's magnetic field and lack of atmosphere. This mission marked the beginning of serious exploration. In 2011, NASA's Messenger entered orbit around Mercury. For 4 years, it studied the planet's geology, chemistry, and structure. Messenger discovered ice, mapped terrain, and took thousands of images. Its findings forever changed our understanding of Mercury. Reaching Mercury requires a series of gravity-assisted maneuvers. Because of the sun's pull, you can't just fly straight to it. spacecraft swing past Earth and Venus, gradually losing speed. Only then can they enter orbit around Mercury. Mercury is surrounded by a thin dust cloud created by micrometeoroids. Each impact blasts tiny particles off the surface. This dust reflects light and contributes to Mercury's faint exosphere. Though nearly invisible, it plays a key role in surface processes. Gravity on Mercury is only 38% of Earth's. A human would weigh nearly 3 times less there. But Mercury's orbit is unstable due to the Sun's influence. In fact, it helped confirm Einstein's theory of general relativity. Scientists noticed Mercury's orbit shifts slightly over time. Newton's laws couldn't fully explain this motion. Einstein's theory of relativity provided the answer. Space itself was curving. Mercury became the first proof of warped spacetime. Mercury's core isn't just large, it's layered. There's a solid inner core, a liquid outer shell, and possibly a sulfur-rich layer. Think of it as a multi-layered metallic cake. This structure explains many of Mercury's magnetic and thermal mysteries. Mercury is covered in deep cracks and ridges. They're the result of the planet's interior cooling and shrinking. Some of these faults stretch for hundreds of kilometers. They are silent reminders of Mercury's aging body. One day on Mercury lasts almost 59 Earth days. The sun rises and sets incredibly slowly. Such long days cause extreme temperature swings. Mercury lives on a very different clock. Because of the way Mercury rotates and orbits, a strange event occurs. The sun can rise, set, and then rise again on the same day. This phenomenon is unique in the entire solar system. Even Mercury's sunrises defy expectations. Unlike most planets, Mercury has no moons. It also lacks rings like Saturn or Uranus. This makes it a lonely traveler near the sun. The empty sky above it emphasizes its isolation. Mercury is one of the densest planets in the solar system. Despite its small size, it contains an enormous amount of mass. The reason lies in its large metallic core. This makes it a truly unique object for study. Scientists sometimes model how Mercury would look with an atmosphere. A thick atmosphere might reduce the extreme temperature swings. Clouds, haze, maybe even climate patterns, it would be a different world. But Mercury remains dry, silent, and bare. Mercury combines burning heat and freezing cold. This is due to its lack of atmosphere and closeness to the sun. It feels torn between light and darkness. Surviving here would be nearly impossible. Several space agencies are planning new missions to Mercury. Their goals include studying its surface, core, and polar ice. The aim is to uncover the planet's deepest secrets. Mercury is still waiting to be fully understood. The Bepi-Colombo mission is a joint project from Europe and Japan. The probe is following a complex path with gravity assists. It's expected to enter Mercury's orbit in the coming years. This will be the most in-depth study of the planet to date. Reaching Mercury's orbit is one of the hardest challenges in spaceflight. The sun's gravity pulls strongly, demanding extreme precision. Bepi-Colombo must slow down at just the right moment. Years of planning go into this single maneuver. Modern probes are looking for signs of Mercury's ancient history. Craters, cracks, and minerals all hold clues from the past. Every inch of terrain holds a story. It's like reading a cosmic history carved in stone. Geological layers on Mercury reveal volcanic flows and ancient impacts. Some areas resemble solidified lava fields. Between the layers are the boundaries of different eras. They are the key to understanding the planet's interior. Billions of years ago, volcanoes erupted across Mercury. They spread lava over wide plains, smoothing the terrain. Today, these volcanic fields remain mostly unchanged. They are frozen moments from the planet's fiery past. Absolute silence rules on Mercury. There is no wind, no rain, no sound, only stillness. It's the perfect place for observation, yet deeply lonely. The entire planet feels like a stage without actors. Mercury rotates in a special resonance, 3 spins for every 2 orbits. This means the same side faces the Sun for long periods. It's called spin-orbit resonance. It shapes the planet's light, heat, and time. Sunset on Mercury is a unique event. The Sun sinks below the horizon very slowly. Temperatures drop quickly, and freezing darkness follows. The transition from fire to ice is almost instant. Mercury's north pole lies in eternal shadow. Deep craters there have never seen sunlight. Yet scientists found ice in one of the hottest places in the solar system. A paradox that still puzzles researchers. Mercury is covered in craters of all sizes. Scientists have mapped tens of thousands of them. Each one has a name, an age, and a history. It's a library of impacts written across the land. Without an atmosphere, Mercury's surface is exposed to solar wind. Charged particles constantly bombard its soil. They knock atoms into space, creating the exosphere. The planet is slowly eroded by sunlight itself. Every crater, crack, and slope on Mercury tells a story. It holds the scars of billions of years of cosmic time. No water, wind, or erosion exists to erase the past. This planet is the oldest page in our solar system's history. Mercury's surface is made of dense, rocky materials. Under a microscope, it reveals tiny cracks, grains, and mineral structures. There are traces of sulfur, magnesium, and iron in the dusty soil. This complex chemistry tells the story of a planet baked by the Sun. Mercury's orbit is the most elliptical of all the planets. Its speed and path are influenced strongly by the Sun's massive gravity. At times, it moves faster than any other planet. These orbital quirks helped prove Einstein's theory of relativity. Without an atmosphere, Mercury is constantly bombarded by cosmic rays. High-energy particles strike its surface directly, altering its chemical makeup. These invisible forces gradually shape the planet's outer layer. It's a slow but relentless transformation. The long ridges and scarps on Mercury's surface are tectonic in origin. They formed as the planet cooled and contracted over billions of years. These features stretch for hundreds of kilometers. They are physical evidence of a shrinking world. Imagine looking at Mercury through the window of a spacecraft. You'd see endless craters, long shadows, and silent plains. No clouds, no wind, just sunlight and rock. It's like flying over a fossil of the early solar system. Mercury's surface is made of dense, rocky materials. Under a microscope, it reveals tiny cracks, grains, and mineral structures. There are traces of sulfur, magnesium, and iron in the dusty soil. This complex chemistry tells the story of a planet baked by the Sun. Mercury's orbit is the most elliptical of all the planets. Its speed and path are influenced strongly by the Sun's massive gravity. At times, it moves faster than any other planet. These orbital quirks helped prove Einstein's theory of relativity. Without an atmosphere, Mercury is constantly bombarded by cosmic rays. High-energy particles strike its surface directly, altering its chemical makeup. These invisible forces gradually shape the planet's outer layer. It's a slow but relentless transformation. The long ridges and scarps on Mercury's surface are tectonic in origin. They formed as the planet cooled and contracted over billions of years. These features stretch for hundreds of kilometers. They are physical evidence of a shrinking world. Imagine looking at Mercury through the window of a spacecraft. You'd see endless craters, long shadows, and silent plains. No clouds, no wind, just sunlight and rock. It's like flying over a fossil of the early solar system. Mercury's surface dust, called regolith, holds a unique chemical signature. It contains sulfur, potassium, and even trace elements not found elsewhere. These clues help scientists understand the planet's formation. Every grain is a tiny time capsule. Mercury has barely changed in billions of years. Its surface holds scars from the earliest days of the solar system. Without wind or water, nothing erases those marks. It's like a museum of cosmic history. Long ago, the sun was younger and slightly dimmer. Mercury orbited it just as closely then as now. But its surface was still scorched, battered, and shaped by ancient forces. That same terrain remains today, almost untouched. At first glance, Mercury looks like the Moon. Both are gray, cratered, and airless. But Mercury is denser, richer in metals, and closer to the Sun. Their similarities are skin-deep. Inside, they're worlds apart. One day, a robotic lander might touch down on Mercury's soil. It would need to survive extreme heat and powerful solar radiation. Solar panels would power its instruments in short, brutal daylight hours. It could unlock secrets hidden for billions of years. Mercury remains one of the least explored planets in the solar system. Yet it holds answers to our biggest cosmic questions. How did rocky planets form? What shaped our solar system's birth? In Mercury's silence, the story still waits to be told.